This is our first video on two-variable statistics. This is a very important skill for you to master. So we're going to go through steps of what needs to be done and one example here, and then we're going to take several more videos to give you some more practice doing this. You need to master this skill if you're going to succeed in AP Physics, and the nice thing is you can definitely do it. So what we have is we have two sets of data and we need to linearize them. We check if they're linear, and if they're not, we need to do a few things to linearize them. So here's how this is done. We first check that the values of both variables are increasing or both decreasing, which is fine, but they both have to be doing the same thing, both getting bigger or both getting smaller. If this is the case, then we move right ahead. If it's not the case, if one of them is increasing and the other is decreasing, then we're going to take the decreasing data set and we're going to take the reciprocal of each of those values. And that will turn the decreasing data set into an increasing data set, which then will match up with the other data set, which is already increasing. We'll show you this as we go along. The next thing we do without a calculator is we check for linearity between the corresponding values. Again, we'll show you how to do this. If you have linearity, you go to the next step. If not, you determine which data set is lagging behind compared to the other one. And then square each of the lagging values and make a new column of data with a new variable and new units. And we check again for linearity. Again, a lot of this isn't going to make too much sense until we show you an example of how we do it. Then we're going to look at the units for our linearized data, and we're going to determine which unit, if this data were graphed, would be most convenient as the rise and which the run. This determination will usually be based on your previous experience with common units in physics. And occasionally there's no best answer for this. But once again, we will show you how this is done. In a graphing calculator, we're going to put the run values in the L1 column and the rise values in the L2 column. We're going to use the linear regression button to obtain the linearized data's slope and y-intercept. And then we're going to report the answer in y equals mx plus b form. But we are not going to use the variables x and y, unless those are the variables applicable to this specific problem. Instead, we're going to use the variables applicable to this specific problem. Smiley face. Let's show you how this is done. Suppose we have this time and distance data, and we want to linearize it. The first thing we do is we check to see that both columns are on the increase. And they are. These values are getting bigger, and so are these. That's good. The next thing we do is we check to see if they are proportional to each other. That is, we check for linearity. And usually you just double things, and you can do this in your head. So for example, from 1 to 2 seconds is a doubling. What happens in the corresponding distance values? 7.7 to 31. Whoa. That's not a doubling. That's way more than a doubling. Let's check another one just to be sure. How about 2 to 4 is a doubling? 31 to 120? Whoa, that's not a doubling. So we do not have linearity here. So we need to change something. And what we need to do is we need to change the column that is lagging behind. And here we said 1 to 2. Well, this goes way more than 1 to 2. So the time column is lagging behind. And what we want to do then is we want to make a new column squaring those times because they're having trouble keeping up. So let's square them. And these are easy to do, aren't they? 1, 4, 9, 16, 25. Once I've done that, I like to cross off that column so I don't get confused and be tempted to put it into my calculator. Let's check for linearity again. So 7.7 to 31, that's about a factor of 4, isn't it? Because 8 times 4 is 32, and 1 to 4, that's a factor of 4. Okay, good. How about here? 31 to 120, that's times 4. 4 times 4 is 16. Hey, we've got linearity now. So these are the two columns we need to put into our calculator, but which goes where? Well, what we need to do is we need to decide who's the rise and who's the run. And the way you figure that out is you look at these units and you decide which one would be better as the rise and which one would be better as the run. And if you go rise over run, you can see you get the unit meters per second squared, which hopefully is a unit that you recognize from earlier studies in physics. So that means that these t squared values are going to be the x values in our calculator, and those distance values are going to be the y values. Let's do that. We're going to go into our calculator here. We're going to turn it on, and we're going to go into stat mode, and we're going to edit. So I hit enter. Now, I've put in the numbers already to save time on this video. You can see that 1, 4, 9, 16, 25, those are my x values. You put your x values in column L1, you put your y values in column L2. Once we've done that, we quit this. Now we go back into stat mode, and now we want to calculate. So you toggle over to calculate. You've got lots of choices here. We're going to go down to linear regression, which is point number 4 on my calculator. I'm going to hit enter. I've put the values in there the way I want them. I've got my x values in L1, my y values in L2. So I'm just going to hit enter here until we get to that screen right there. And that tells us, according to what's on the screen, that y is equal to 7.556x plus 0.622, something like that. Now, many students want to stop there because they think they've linearized it, but the final step is we don't use the generic variables y and x unless that's what we have in the problem. What we have in the problem is x needs to be t squared, and d might be a better variable for the y values. So here we go. D, the distance, is equal to, and we're going to not be too picky about sig figs, but I'll just round it to 7.6. But I don't want x here. See, I want t squared plus 0.62, whatever. We'll take a couple more videos and show you some more examples.